When we were last together as a group, we talked about the ratio and the root test, and we talked about our rearrangements. But at that time, and then throughout the presentations yesterday, I heard student after student say, but how do I know which test to use when? And if you will, you're asking an analogous question to the one you asked in Calculus 2 when you were learning all your integration techniques, and you said, how do I know when I'm supposed to use partial fractions? How do I know when I'm supposed to use trig sub? Like, how do I know when to use integration by parts? How do I know? How do I know what to substitute for? How do I know what to do this? In retrospect, when you think about Calculus 2, I think it's safe to say that the best way to know is to practice a whole bunch, right? That the more you integrate, the more comfortable you're going to be in determining what method to use for integration. Same thing is true for infinite series. The more you work with them, the more you play with them, the more comfortable you're going to be. But just like there were some tricks of the trade, so to speak, to help you integrate, there's also tricks of the trade to help you determine whether a series converges or diverges. And so today we're going to spend some time talking about strategies for testing series. All right. Questions before we dive into these strategies? Very good. All right. So let's begin by reviewing the list. So what's on our list? We have geometric series, harmonic series, telescoping, integral test, test for divergence, p-series, comparison test, the limit comparison test, the alternating series test, the alternating harmonic series, the ratio test, and the root test. Wow, 12 different items. That's a lot. And so rather than focusing in specifically on what to do when, let's kind of break down the list into some various parts. So I want to start by pointing out that there are 4 famous series that we played with. And so we've played with the geometric series, the p-series, the harmonic series, and the alternating harmonic series. These are like famous examples that get referred to. They generally speaking don't fully answer a question, but they're easy examples that we'll refer to, especially when we're doing things like comparison tests. And so we're doing a comparison test or a limit comparison test, and we're like, well, what do I compare to? Oh, let me compare to one of these scenarios. Or if you're trying to understand a theory or a theorem, then oftentimes you can understand it by comparing it or applying one of these kind of known famous series to the new situation. And so in particular, what I want to point out is that these are not tests. So they're not tests in particular, they're just famous series. If you happen to get one of them, then you know what to do. But yeah, they're not really tests. Any questions about these famous series?
Are there any more series, or are those like the only ones?
Oh, I think there are many. There are many series. These are just the ones that we're playing with in this class. Like an example, I think an example of another famous one that we don't have here is, remember right, it's the sum from n equals 0 to infinity of 1 over n factorial equals e. So,
oh yeah.
So this would be an example of another famous series. It's just not one of the ones we're playing with here.
Okay.
Yeah. And when you were doing Calc 3, you talked about things like the Maclaurin series, which were giving you power series, but those are examples of other really famous, powerful things. They're just not what we're playing with at this point. Other questions? Very good. All right. So I tried to make a chart to see if this would help you track what's going on. So I wanted to help you by help you figure out what to do by classifying series in the following way. Are they generally speaking easy to apply or hard to apply? And are they weak? And when I say weak, what I'm saying is weak would be a reference to saying it doesn't usually work. It doesn't often help. And of course, strong would be works a lot. And so I thought we could try to organize our tests in this manner, and it should, I hope, be clear that what's the worst box of these four? What's the worst scenario?
Top right.
Yeah, this one's bad, right? We want to avoid this one if at all costs, or if at all possible. And what's the one that we want to try first?
Bottom left.
Yeah, this is the best. The upper left, well, it's easy, so you might try it. It's not that big a deal. The bottom right is, because it's strong, it's worth doing every now and then, but you probably want to at least consider all the easy stuff before you do the hard. So it's almost like our priority list is we're going to try this one first, and then we'll try this one, and then we'll try this, and then only in desperation will we go there. Now, it's not always as simple as just going, try the 1, then the 2, then the 3, then the 4. Sometimes you'll look at it and go, well, I actually know what's going on, and you just have to go straight to the test. That's the best. But if you're just sort of in a vacuum and you don't know how to proceed, you're just guessing, for lack of a better word, well, then start by guessing things that are easy and strong, and then kind of work your way from that point. Does this type of prioritization make sense to everyone? Cool. I think about my computers. I got a new computer. I had blue screen of death yesterday again. I think it was yesterday. But I think about computer fixes. And I think about the most famous computer fix of all is reboot. Right? Like, did you turn it off and on again? Does that work? Yeah, that's easy. Does that fix things? Not very often, but it fixes things enough that we should try it early. Hard things that are strong, like you could do a full reinstall. Usually that will fix everything on your computer, but it's a pain in the neck, right? Things that are easy and strong, well, you could maybe update your system, and you check for viruses and think those kinds of things as well. So kind of by analogy. Does that make sense? Very good. All right. So let's, using that theme, let's look at some of these series. So the very first test is the test for divergence, also known as the divergence test, depending upon which text you look at. And what we have is that if the limit of the terms doesn't go to 0, then the series diverges. How often does this work? How often, I mean, think about the assessment you just took. How often did this test apply?
Not often.
Not often. It applied once, like on there. So it doesn't apply very often, but it's really easy to do, right? So since it's really easy to apply the test, we try it first because, I mean, you usually don't even have to write it down, but you can pretty much look at the terms and go, do the terms go to 0? Yeah, keep moving. If they don't go to 0, then maybe write something down. So super easy, barely an inconvenience, works very rarely, but so easy that it's always worth trying. The direct comparison. I went back and forth on how to rate this. Is it hard and weak? Is it easy? Like, this was a hard one, but having just graded everyone's assessments, I think I'm pretty comfortable with saying that it's hard. And the reason it's hard is because it involves inequalities. And inequalities are a pain. I don't know how else to say it. They're just a pain to work with. So it's got inequalities, and we end up with this table that we've talked about before, where if that known series is bigger and converges, then it pushes the unknown one into convergence. If the known series is smaller and diverges, then it forces the known one to diverge. But we have these two evil spots of inconclusiveness that tend to trip us up. So if you want to use the direct comparison test, notice you sort of have to do two things. You have to sort of guess something to compare to. Guess a comparison series. And then you have to then verify the inequality. Does questions about the direct comparison test? What kinds of things would be good candidates for comparison tests in general? In general, we would be looking for the direct comparison test when we're at what kind of series or series-ish stuff.
Known series?
Yeah, well, known, and then what kind of known?
Or geometric. Geometric, yeah.
Yeah, usually this will either be geometric, or even more common than geometric, it would be probably a P-series. These are the most common. So you'll find that you'll use the comparison test most when you have stuff that's almost geometric or almost a P-series. That was odd.
Blackboard, huh?
I'm like, I don't even quite know what just happened here. Oh, yes, I do want to hear about George Clooney. Okay. So back on our shared screen. Somebody remind me at the end of class to send a note to this poor student, Deb Wilson. Or I think that was a teacher, if I'm tracking right. Okay. Whew.
Well, if she is, she's not showing up in the faculty directory for Highline.
Oh, that's weird. Yeah, we don't even have Blackboard, which is confusing too, right?
How'd she get in here?
I have no idea. Like, was that entertaining or was that confusing or a little of each?
That's free TV.
It was pretty funny.
Okay, good. You guys are all very quiet. It's like the way the person comes into your classroom, but now they're coming into your, like.
Well, it's like with her last name, I'm like, is she like related to you in some like capacity? And
Not that I know of. Yeah, I mean, I don't know. I got a lot of relies, so maybe. But
It's kind of funny how she didn't like ask like how you were, like who you were either. She just like was like, okay.
I know. I wonder if, yeah, I have no idea. But it was entertaining. So, yeah. Oh, yeah. Nice try, Enrique. Okay. So anyway, back on track. So comparison test, best with when you have something that's almost geometric, almost a p-series, but it's a pain because you have to check inequalities, and inequalities are just not our friends. I mean, they work, they're just not our friends. So pro tip in terms of comparison test, think about whether if you drop, usually there's a fraction, if you consider dropping something, would that give you a known series? All right, limit comparison test. This is our first really nice example. It's easy, it's strong. And so what are you gonna do? You're gonna calculate this limit, and if the limit is finite, then they either both converge or both diverge. This is where I use the phrase in class that they share the same fate. This is the Superman and Lois Lane video and the incredible stuff with no capes. And then there's a couple of special cases here, and at least one on your assessment did a nice job with this, that if the denominator term, if that series converges and the limit goes to 0, then the upper one will converge. And if the denominator term diverges, then the upper one will also diverge. So these are kind of these fringe cases that don't come up very often, but every now and then do come into play. The reason why it's both easy and strong is because it works a lot, hence the strong part, but it's easy because there's no inconclusive category. There's no inconclusive category. There's no inequalities that are needed. So what I would recommend is that you try the limit comparison test anywhere where you're tempted to use the comparison test. So anytime you're like, oh, I should try a comparison test, then like slap yourself on the face. No, I should try the limit comparison test, because it will probably, it will work just as well and perhaps save me some pain and anguish. Questions about the limit comparison test? Very good. I don't like the integral test. The integral test is hard. The reason it's hard is it requires integration. I'm pretty good at integrating. I've evaluated a lot of integrals in my life, but it takes time. One of the things about integration is there's lots of notation. You know, like don't forget those dx's. You know, when you change, if you use substitution, you got to change. You got to change your limits of integration. Oh, this is an improper integral, so now you have to include limits in it. There's just all kinds of notation that's involved, and that's even with simple integrals. And so there are times when we need the integral test, but in general, I would encourage you to avoid it if one of those other tests work. For our class, what was the purpose of the integral test? We needed it in order to get one particular result. You guys remember?
Approximate.
Say again?
Approximate.
We were able to approximate, that's true, but it gave us one of our known series. Do you remember which one it gave us?
The harmonic series.
Or more generally, so it gave us the
shows that
harmonic
it
series.
diverges.
More generally, it gave us the P series, the harmonic series just being a special case of that. And so if you think about how the class is structured, the integral test is easy to understand conceptually, but the reason why we need it is because it gave us our P series, which then became bread and butter when we did our comparison tests later on. Very good. Worst, like the worst of the worst is this telescoping series. Sometimes it works, but it's super rare. It almost always requires some cleverness, some sort of algebra. And so this is, I mean, if you look at a series and you see that you could use the telescoping series, great, more power to you. But in general, this is sort of what you try when everything else has failed. So best tip, or pro tip, put it off as long as possible. Keep going. Good. All right. The alternating series test is another one of those easy weak tests. It's really easy to do because you just get to evaluate the limit. And evaluating the limit is easy. But what's the problem with the alternating series test? Like, what's the issue?
It only works on alternating series.
Well, okay, true. So it only works on alternating series. So maybe it has limited application. But suppose you have an alternating series and it works. You still have what's still the issue you have?
Whether it's
Doesn't it have
to be non-increasing.
Yeah, you sort of have some things to verify, but the thing that I'm pushing for, somebody just said it, is you still must determine if you have conditional or absolute convergence. So it's like you can do the alternating series test, it can be successful, and you're still not done. And so that's why I would tend to say it's weak, because it's like you do it and you end up still have, only a quarter of the way into your question because you have to determine whether or not you have absolute convergence or not. That's why, part of why the next couple tests are so nice, that the ratio test and then the root test both give you absolute convergence. And so if you have the choice of using the ratio test or the alternating series test, then just try the ratio test because it can give you the whole thing all at once. In general, the ratio test is best when there's factorials or when there's powers of n. When will it fail? I mean, it's written right here in writing. When does it fail?
P-series.
Yeah, don't do it with the P-series. What would happen if we did it on a P-series? It would end up being, what result would we get out?
Conclusive.
Inconclusive, exactly. It's like the worst result of all. It's inconclusive.
Wait, so how do we know when it's a P series again? Is that just if it has a value in the
P-series,
exponent?
Think like polynomial divided by a polynomial.
Okay.
I mean, that's not a P-series is much simpler than that, but it's P-series-ish if it's polynomial over polynomial. Yeah, very cool. So I just want to pause here and focus in on this number 1. Okay. So let's just think about what 1 could mean. So with the various tests. So suppose you got 1 and you were in the divergence test. What would that mean?
Diverges.
That would mean it diverges. Okay. What about if you had 1 and you were on a P series?
Diverges.
Because in this case, one would represent which series?
Harmonic series.
This would be the divergence. This is a harmonic series. Okay. What if we had the limit comparison test? What would one mean?
Depending on the
A and then
series
B n.
used,
The B
it
n.
could be convergent or divergent.
Yeah, so it would tell you that they're going to have the same fate, right?
Same fate.
Or same out, both converge or both diverge. And then if you have the ratio or the root test, this would be inconclusive. Right? And so what I want to point out is that we run these tests, but you have to understand how to interpret the results. And so just getting saying, well, the result of the test was 1 is not sufficient. You also have to know, oh, if this 1 is in the context of the ratio root test, that means it's inconclusive. Try something else. Oh, it's in the context of the p-series, that answered my question. Oh, it's in the context of the limit comparison test, that means I have the same fate. What was that fate, right? It was that convergence or divergence. Oh, I need to know something else in order to be able to answer that question. And so this isn't difficult. It's just you have to sort of understand what you know and what you don't know. Questions about this? Very good. Root test is the same. The one comment I would make on the root test is that it's best used when you just have a power of n, but nothing else. So I can tell you that I would tend to use the ratio test before the root test, because the ratio test will usually work when the root test does, but oftentimes not the other direction. So ratio test is a little bit more powerful. So there's kind of this summary of all the options, and then here's the important table. So notice that I put, which ones did I put here? I put the famous series. Here's the famous series. They're all showing up under easy weak, along with the test for divergence, alternating series test, and I put the root test. And the reason I made it weak is because it just doesn't apply very much. My go-to friends, my favorites, are the limit comparison test and the ratio test. And then you'll notice that I'm sort of undecided in where to put that comparison test. I keep labeling it in multiple places. But the comparison test and the integral tests are ones that I'm tending to avoid if I can. This one, because it has inequalities. This one, because it requires integration. Those are the things that make it hard. And then the last resort is that telescoping series situation. Questions? Very good. How would you like me to proceed?
How? 17.1.
17.1. Well, I better start working on my notes for that. 17.1. Let me talk a little bit about chapter 17, where we're going. I think it'll give you some context. So chapter 17 goes back to the heart of calculus with integration, and we're going to introduce two new types of integrals in the chapter. We're going to introduce what's called a line integral, and then also a surface integral. And there'll be some new applications with work being one application, flux being the other most common application. It tends from a computational standpoint, the questions tend to be pretty straightforward. The challenge ends up being that it's harder to visualize what's going on. But I feel like if we start talking about 17, then maybe we miss out on the series stuff. So let me just pause on the series and say, I think that this chapter 10 stuff that we've been working through with infinite series is challenging. It's challenging in figuring out how to organize your thoughts and putting together a nice coherent logical argument. It takes some practice, but relative to the other things you've done mathematically, you're all totally up to this challenge. You can all totally do this stuff. And I think that with the practice, everybody's going to knock it out of the park this coming week. So I'm pretty confident that this is all going to start working for folks. The best solution you can have is to knowing what to do and when to do it is to practice. And if you're not sure, ask questions. Ask your peers. Ask Tran at the Math Resource Center. Visit office hours, set up an appointment, talk to me. Let's work together. But you can all do it. It's just a matter of spending the time, taking the time, and paying attention to those details. So I think what I'd like to do, if there are no objections, is maybe I'll let you go a little bit early. And if people have questions, I'm happy to hang on the line and do examples or respond to questions. But we don't get out early very often, so maybe we can make up for a few days that went long today. Okay. Thanks, everybody. Have a wonderful day.
Thanks for the lecture.
Jesse, thanks. I appreciate it. Thanks. Bye-bye.
Bye-bye.
So
Go ahead. Somebody kick it off. I see.
Sorry, I walk up the stairs and talk at the same time. I just think.
Bye-bye, Twee.
Oh no, I actually had a question.
Oh, go ahead.
So can we go to the assessment? Because somehow I lost 3.5 points instead of 1.5. Like the way you mark it.
Let me see if I can look. Let me see. 1, 2, 1.5. I thought. Oh, okay. This is going to be a question on what did you change on the resubmit. That's what's going on, Twee.
Oh, so just you see the last pay, the pay. What is it?
Where you redid question 1?
Oh no, question number 10.
Okay.
Yeah, so I changed the sign. Remember when I talked to you, I found out that I did the mistake. I
Mm-hmm.
put the equal sign instead of the less.
Mm-hmm.
Yeah.
So I can do Making myself a note.
Oh, so you subtract me 2 points for the late submission?
Exactly. So I can go back on that one.
Okay.
I got it.
Because when we talk, you said you only like subtract me a point on half.
Yeah,
Point,
exactly.
point and
But I
half,
didn't
point,
track all those
point,
things when I wasn't able to keep track of those things when we were having the conversation.
Yeah, I know. So when I saw the total, I said,
You're like,
"Oh, but I
what?
lost another 2 points."
Yep. So that's what's going on. Cool. I can take care of that one. Let me see if I can answer the next question if that works. Jason?
Hey, Dusty.
Hey.
I think you misgrade in my question number 10.
Let me pull it up.
I think I didn't get point for that. Instead, I get the playing modern days.
Oh, that's weird. Mm-hmm. Yeah, you're correct. So I Mother's Day'd you twice when I should have once, right?
Yeah, I wish. I wish.
You wish. Okay. All right, I got you. That one's just my error. So
All right.
+2.
That's all right.
Okay. Cool. Thank you.
Thank you, Dusty. See you tomorrow.
See you tomorrow. That was 1.
Okay, now I see it.
Cool. All right. Other questions on? Are there other grading questions while I've got stuff up and I'm thinking about it?
Oh, I think I see it now. I think I mistake a plus sign because I put this. Okay, I think I see it. I lost half of a point in question number 1.
Mm-hmm.
But I see you put a plus sign there. I think that's when.
Yeah. Yes.
Yeah. Okay, I see it now. Okay.
Got it.
Thank you. Yep. And question number 2. I know you got 0.499 something, but when I calculate it, it's only come out 0.5. I don't know why. I don't know. Did I calculate it wrong?
I wonder if it's a rounding thing.
You think? Yeah, because yesterday I saw it on Damon and one of another one, and I tried to like use my calculator, and it still come out the same answer. I'm like, what's wrong with me? I don't know why.
Do you want me to pull it up on the calculator?
Yeah, that would be awesome. Did I punching something wrong?
Let's see. Dun, dun, dun. All right, can you see my calculator?
Yes.
Okay. So I want to enter the sum from x equals 1 to 10 plus. I'm not working through it. I'm just trusting your work at the moment. 1 over ln 3. This is what I see in your work.
Yeah. Huh.
I have no idea.
Something wrong. Okay, so I might punch something wrong. Let me check it. Okay, it's okay. It's only half of a point. It's just weird because I saw it on Damon when you asked Damon that question, and then I didn't ask that question too, and I tried to dig and said, "Why is it come out? Why?"
Yeah, I don't know the answer.
Okay.
Good.
Thank you, Justin. Since I hate you here, can we talk about the remember the email I sent you about the
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 advising?
planning for
Yeah.
how?
Let me see
Yeah.
what Enrique and Robert have, and
Okay.
if you can hang on the line, we can
Yes.
definitely do that. Yep.
Yes.
Yep. Enrique, Robert,
I'm just chilling.
just chilling. Cool. That chilling's good. Robert,
Oh, I was just going to let you know, you might have a fun time trying to respond to this Deborah Wilson, because there isn't one on Highline's faculty. I found 2 that teach English throughout the nation. One's at Illinois Central College, and the other one was at Arizona Technical University.
no way.
And only one of them, the one at Illinois Central College, teaches 100 level.
Oh my gosh. Now, okay. This
Got
is
a
like
data operator over here. Woo!
this is like way more entertaining than I would have thought. And then she gave us a section number.
Yeah.
Is this the Illinois Central College? Is that what you mentioned?
Yep.
Oh my gosh, that would just be like so much fun.
Because I only found one that teaches 100 level English in the entire country.
Uh-huh.
So there was someone in need out there, and they knew the right person to come to.
They,
How can she find you? That's
Uh,
interesting.
Someone
Yeah.
just said, here is the Zoom channel. Just click here, and you can get your answer.
I mean, she must have just typed in the wrong number and it just happened to work.
I guess it's possible, but oh my goodness, that's ridiculous.
Yeah, the odds of that are so low. That is just like the funniest. So we should email her. Okay, so do you see your contact information here somewhere? Did you have it earlier?
No, let me see if I can pull that up.
Yeah, because you got to help me compose a good email.
Oh, I have to?
Well, you don't have to, but I mean, this is half the fun, right?
I guess. So we're looking copy. So let me see if I can pull up their faculty directory.
Nice.
And this was at Illinois
Central Community
ICC.
College.
Let's see. Hey, guess what? I may have her in the faculty directory.
Nice. Is it something clever like Deborah.Wilson?
I'll let you know as soon as I can
Okay.
find her. Theirs isn't as intuitive as ours for some reason.
Ridiculous.
Wilson, Deborah. Believe it or not, it's D. Wilson at icc.edu.
Nice. I could do that. Okay. Okay.
That is funny.
I gotta try a classic, turn it off and turn it back on. Talk to y'all later.
All right. Sounds good.
I find this mildly hilarious for whatever
It's
reason.
just funny that she show up and she didn't realize that there are many people in here. And then
Yeah.
she just like start talking like it's. I
Yeah.
think you were right. Maybe she punched in the wrong number and it just accidentally to be your number. Funny. That's why we're confused when she asked for English 101. Is it in math class? Why would she ask you for English?
I'm like, how does English fit into pure and applied sciences?
I don't know.
I mean, it is what it is, but dang. Although, I'll tell you what, I'm a researching fool.
I'm impressed.
Don't get on Robert backside. He can fight you.
All right. Is that both respectful and slightly entertaining? Like I told her I had to respond, so.
No, it's perfect.
All right. I'll let you know if I hear anything. I mean, she's probably,
This could be the start of like some pen pal.
yeah,
thing.
exactly. Oh my gosh. And like you said, or somebody said, the idea that it's a person with the same last name is, I mean, and even the same first initial is like,
Yeah.
this is just so bizarrely coincidental.
Well, it's ridiculously odd.
Yeah.
That's the way I would put it.
Yeah. I agree with you.
But no, the ability to research that quickly, you can blame Jen Heckler for that.
All right. I will.
I took her honors 200 class.
Uh-huh.
She's big on the research side of things, like making you dig. Which it's good, especially when you're in the hunt for a university and a program and scholarships and researchability is huge.